Alrighty. There we go. And yeah, I guess just kind of a top down real quick. Let me see the rocket from. We'll start at the nose cone. Start with everything exterior, and then I'll work my way to the inside of it.
Ah,
So, do you have the nose cone to show?
yeah.
Hold it up. We do have a slides presentation for you.
Do you want to do that, or you'd rather just us walk through stuff?
If you have a slides presentation, we can quickly go over it, but definitely the main part is to see the progress of the actual rocket. But yeah.
All right, we'll start with the nose cone.
We'll just show.
Okay, so here's our nose cone.
There you go.
Okay.
Right.
Nice. All commercial.
Yeah, this is commercial 6-inch nose cone from Wildman Rocketry.
Okay.
Fiberglass.
Pull it open.
There's a 6-inch top shoulder on the coupler, and then pretty much this is just gonna house our main parachute.
Alrighty. So those tips thread on. Is there anything holding on going into that thread besides holding the tip on itself?
So there is a kind of hard to see because the way it's assembled, but there is kind of a little bit of a threaded rod that goes into the tip, and on the other end of the little like disc that they use to hold it on is kind of like an aluminum extension for an eye bolt.
Okay.
So our eye bolt is like with an aluminum extension, and then that threaded into the tip of the nose cone.
Should I hold this up?
I can open up our CAD if that makes it easier to understand, or does that make sense?
Yeah, I use Wildman nose cones on several rockets. So, for the eye bolt, do you have anything to keep it from unthreading itself while it's coming down under chute?
It's Loctited in with so we put Loctite on all those threads except for the one on the very tip. So
That works for me. What else is inside the nose cone?
basically it's just our main parachute and then all the shock cord for that.
We have shock cord protector and a fire blanket as well.
Yeah.
Okay.
That's basically it. It's in there.
Yeah. So let's move down to the tube that it connects to.
So here's our eye tube. We do have to drill the holes for the shear pins and stuff in it. But it's basically it's a 6-inch blue tube. Then this has 2 layers of these solar composites, like fiberglass sleeves on it. And then we used System 2000, was it laminate epoxy? To
Very good. Well, how many and what size shear pins are you planning on using?
So we have, so both our separations have 4 M2.5 nylon screws for shear pins. Based off our testing of them, they should break about like 35 pounds each. It'd be like, I think we said it's like 140 total.
Very good. Very good.
Shear everything.
We do have them. It's these guys.
Very small.
Nice. And is there any bulkheads or couplers that attaches to that section?
Like, in the body tube.
Right.
So in the body tube is going to house our like avionics bay with our charge wells for the black powder.
We have that system here.
Basically this whole thing kind of just
Try to hold it up to the.
Very nice.
that kind of gets slid into it. So the
Okay.
We can go over that.
wait a minute.
How does that?
What?
I was just gonna ask, how does that attach to the body tube?
So each bulkhead. So basically there is on each of these aluminum bulkheads, there's 3 quarter 20 screws that go into it on each side, and that's kind of how they get attached.
Alrighty. You said 3 quarter 20s?
Yeah, on each bulkhead.
All right. Have y'all done any kind of stress analysis to show that 3 of them will hold?
We haven't tested them, like the recovery system at least.
We have not on the like max of like our we're kind of expect like not radius, but not in terms of like will they like rip through the body tube, but we have the hold in terms of the force exerted during the ejection charge, but we can run those.
We can run those. That's bad.
Yeah. I think that's when you're attaching anything, it's really good to know what the strength or where it's going to break. I don't think there's any problem. You don't need to show me anything for that. But if any of your team members are curious, it's a good idea for any attachment just to understand when or if it's going to fail.
Yeah. All right.
But yeah, since there's really not going to be much pressure on those, I'm not worried about it. So how does that tube connect to the booster section?
So and that connects. So for that we have a the 12-inch long filament wound coupler from Wildman Rocketry.
Yep.
This is currently still making one of the parts for this, but basically this connects the two tubes together, and then on one end there's going to be a aluminum kind of cap that goes about like, what is it? I think 2 and like 3/4 inches in, and then it's got a shoulder on the back, and that's more of just so we can seal off the parachute bay to make it just slightly smaller, and then gives us a place to attach the eye bolt for that.
Okay.
We're still we're halfway through making that part, but
are you also planning on somehow preventing that eye bolt from loosening as well?
So that eye bolt will have it's going to be basically threaded into that aluminum plate, and then we're going to have a nylon nut on the back side of that. So the thread's going to extend through, and then we're going to have a actually I can see it. So go up on this one. Basically, we have our eye bolt. It's the same kind of setup as this. So we have our eye bolt, and then there's nylon like lock nut on the back side.
That works. Looking really good. Let's see what else. That coupler, how much of it is going in, or what length to each section?
So, so the total length is going to be like 12.2 inches, and then like 6.2 is going to go into our aft body tube, and then 6 into the main body.
Okay. And your airframe 6 diameter?
Yeah. Yeah, so we're a 6-inch diameter airframe.
Perfect. Sorry, I lost video there for a second, but I got it. Let's move to the fin can section. Tell me about your fins and the attachment on them.
All right, so our fins are, let's see, 1/4 inch thick, G10 Aerolite. They are like through tab, the body or through wall on the body tube, and then we have G5000 rocket epoxy fillets on the outer edges and then on the inside edges. And our fins do have a SLA printed edges on them to kind of taper them.
Oh, nice.
Yeah,
what material SLA?
So SLA is so those are. So we used the Formlabs printer. So we used the Formlabs Gray V4 resin.
Okay.
So they're basically 100%. They're solid. Like there's no way the SLA works. It's like 100% solid on those. And then those are attached with the same G5000 rocket epoxy.
Did you do any, or can you explain to me what you did for surface prep for the fins and that part before you epoxied them?
So we just we basically just sanded them with 60 grit sandpaper, and then cleaned it with some like isopropyl alcohol to get the dust off.
Perfect. What diameter or radius is your fillets? Do you know?
1/2 inch radius. 1/2 inch radius.
Very nice. That should work well. Okay, what about your rail buttons? I see your bottom one there.
Yeah, so we just have the bottom one installed, but there's going to be puts it up. So there are 15 rail buttons from Fruity Shoots. And we're gonna have three. We only have the one on here right now, but there's gonna be one here. One. So this is in the aft centering ring. Threads into that. There's another centering ring here, which is we're gonna have one here, and then at the top is going to thread into the that aluminum cap on the end of our coupler.
Okay.
So we're just gonna have those three in those locations.
Very. So that's going into the top coupler there.
Yeah.
How's that coupler gonna be mounted?
So in this tube, the coupler is going to be mounted with four quarter 20 screws that go through the body tube into that aluminum cap on the end of the body tube or end of the coupler. So that's how attached to this one. On the other side, there's going to be the same 4 shear pins.
Okay.
Yeah.
Have you taken a look yet at your location of all of your external bolts to make sure they're not in the line of the rail button?
So these three, we're going to have our rail buttons, and then the above this, we I think are going to have 2 of those quarter 20 screws that are on our avionics bay that will maybe in the same line, depending on how well we drilled these. But all the shear pins are offset by 45, so they're basically in line with the fins. And those are
I'd
all.
say if you could definitely do a dry fit to see if you
Yeah.
can avoid it being in line. We've
Okay.
definitely had issues past years to where those bolts stood a little bit too proud and they would hit the rail, and
Okay.
then the team had to go back with a Dremel and see what they could fix.
Okay. Yeah. We still have to drill the holes in the for those, so we can adjust that a little bit if we need to.
Perfect. What about motor retention? What do you have on the bottom of it?
So we have a 75 millimeter flanged retainer from Aeropack.
Yep.
And that's bolted onto the aft centering ring.
What material is that ring?
6061 aluminum.
Cool. What about your motor tube on the inside?
So the motor tube is a piece of 75 millimeter blue tube. It's about like 15 inches long. And we have a centering ring on each end of that, which is epoxy to that tube using the G5000 rocket epoxy.
Cool, cool. So structurally, the outside looks beautiful to me. Looks really, y'all put a lot of thought into it. Y'all have had some really good craftsmanship there. Out of the teams I've reviewed, I'd say you're the furthest along. Let's get into the recovery. What do you have going on there? Talk to me about your recovery harness and connection points.
So for recovery harness, we have 1 inch tubular nylon shock cord. I'm going to share a diagram that we have.
Sure.
It shows like the lengths because it'll be easier to like just kind of show it that way. Oh, wait, no. Okay, so basically, it's, 1 inch tubular nylon shock cord. And this is kind of just how the lengths are going to be and how they're going to be arranged. For that. So, yeah. And then for attachment on either end, we basically have the eye bolts. There's 1/2 inch steel eye bolts, 1/2 inch steel quick links, and then in some places we're using 6 millimeter Dyneema saw shackles to help kind of reduce some weight.
Was that a big recommendation from Ken on those soft shackles?
Yes. Yeah.
He likes those.
Yeah.
Go back one slide to
The this
parachute locations. Yes. Can you tell me why the main is positioned where it's at?
in terms of just location of the body tube or just distances from body tubes.
Yeah, the distances from the body tubes.
Um, so I'm trying to. I wasn't the one who got the distance. So yeah, so and partially the distances are so we don't have, I guess, like the pieces don't hit to get each other when they're when the parachutes are open. And then as far as the lengths, we had some other members go through the research process of figuring out how long to make them, and they're not currently here, so I'm not 100% sure on the that portion. Um, but
So I know you mentioned that part of the reason is so they don't hit each other. Kind of what I'm looking at the main at its position is with the nose cone portion being 21 feet and the aft end portion being 10 feet. That nose cone is going to be hanging down and could collide with that body tube.
at the main body, like this middle body
The
tube
middle
section.
section, yeah, yeah.
So I think the math, yeah, I guess there is a possibility. I know there's like a 4 foot difference.
Double check that.
Yeah, we'll double.
Yeah, just take a look at it. It's of course
It-
nothing serious because the possibility's low, but I
uh,
have had aluminum tip nose cones kind of dig into my body tube before because I didn't space it right.
I think if I'm doing the math in my head, it's the distance from the main the like main chute connection to the end of the main body tube is like 14 feet. The distance from that same point to the tip of the nose cone is, well, no, to the base of the nose cone is 17 feet. So there's like a 4 foot gap between them, but
Okay. Yeah, I'm good there. So, are you using sewn loops or knots on the end of the nylon?
so nylon is sewn in loops. I'll stop sharing. Um, so they're
Okay.
sewn in. Um, yeah.
Perfect. Have you been able to do any tests, either flight testing or even just computer simulation on your size of your parachute versus descent rate with your current weights?
So we've been so we've done simulation both Open Rocket and RAS Arrow. And with our main chute size, we're looking at a descent rate of like 96 feet per second at like its highest. And then with, no, wait, my bad. That was the drogue chute.
That sounds right.
Chute, yeah. The drogue chute has 96 feet per second descent rate, and then our main chute is 15.5 feet per second, I think.
Very nice, very nice. What else? I guess the electronics. What electronics you're using, where are they going, and how are they mounted?
So for our flight computers, we have.
It might be easier to pull up the slide.
Yeah, I'm
about
thinking pull
electronics.
up the slides for this one,
Sure.
just because we pivoted our approach less
Yeah, I know
than
Zach
a
sent
month
you
ago.
an email, I believe. Yeah, that one. Aiden, if you want to talk about it, take it away.
All right. So currently we're using a power supply to get from our 9-volt battery inputs to a 3.7 volt output to power each of our flight computers. We have 2 separate power supplies, one for backup, one for primary system, just so we have that redundancy there. And everything's on separate boards. They're in the same area, but they're on separate boards.
Mhm.
And so we have one flight computer. We have the Telemetrum for our primary system, and we have the Easy Mini for our backup system. And then each power supply is going to have two 9-volt batteries as its input and output 3.7 volts, basically to mimic the LiPo that would have been there before before LiPos were banned.
Right. Alrighty, that looks good. Do you have any picture showing the setup of
Yeah.
how they're going to be mounted or oriented?
Yeah. So we're not currently we only have really the Easy Mini on here, but
I can grab a board if you want me to grab it so we could show him where it would be placed.
I have so basically in our avionics kind of setup, we have basically on standoffs, we have right here is the Easy Mini.
Oh, nice.
And then it's not on here right now, but our telemetry will be here. And then those boards for the batteries are going basically here
Okay.
on standoffs. That's all.
Are they going to be zip tied to those brackets or?
We can if you, but we weren't currently planning on. But
Yeah, without seeing the batteries mounted, I'm not sure.
for the mounting the batteries.
Yeah.
So the the batteries are we have connectors soldered to the board. They're basically full enclosures soldered to the board that get
Okay.
bolted onto the board, and then we're planning to I think the plan was to strap around that
There's like
holder.
kind of a little bit like 3D printed strap that goes
Okay.
over that, so that kind of holds it into that bracket or that 9-volt connector.
Very nice. What material for that 3D print?
These are just PLA,
Okay.
but they're fairly small and quick to print, so we can change that material out.
Yeah,
It's
it's
kind of the
it's
first ones.
definitely something to think about, especially when you're sitting on the pad for an
Yeah.
hour or two out in the desert. Inside the rocket, you have less of a chance of something going wrong, but when you look at the transition temperature for PLA, it's quite low. So
Yeah.
I would take a look at it and see if you want to redesign it out of ABS or
Yeah.
PETG.
All right.
What else? What about your payload? What do you have going on there?
All right. We're doing like a CubeSat design format. So we're gonna do 3U in length and 1U width. We were originally planning on doing steel plates that were laser cut. I picked like a triangular formation that was gonna reduce some of the stress that it accumulated, but we're having some technical difficulties with a water jet for the past couple of months. So instead, I'm in the process right now of designing. It's going to be acrylic plates, like an acrylic box. And it's going to hold about 8 pounds of steel that's going to be attached in numerous places at the bottom. And then at the top is going to have our Raspberry Pi and all our sensors on a board. The main thing is just so that it can gather data so we can plug it into our neural network at the end of the flight.
Okay. So for all that, the mass that you're going to be added, can you explain a little bit more on what y'all's plan to secure it and make sure it stays in the rocket?
Yeah. So what I've been toying with, and I'm still working it out on SolidWorks just because I've been running simulations through ANSYS to get it narrowed down as to what's going to work the best. But what it's looking like right now is we're going to have kind of like an acrylic box. We've got some brackets, so I'm gonna bracket the sides by the steel, and then the plan is possibly 3D printing a holder as well for like the box that has a couple different screw holes, just to minimize any sort of breakage, because that was my first concern too, which is why I would have rather welded it together. But Alas, time
Very
constraints.
good. So I know y'all mentioned once or twice about the model. Is that something you can pull up and show real quick?
The CAD model.
Yeah, the CAD model.
Prepared.
All right. Right now the payload is kind of a placeholder, but this is kind of just a section view of our rocket. SolidWorks.
Very nice and detailed. I like it.
Yeah, so this is what we're talking about with the eyeball, like with the aluminum extension earlier with the nose cone.
Yeah.
Yeah.
I see that right towards the left. It looks like an external shroud. Is that for a camera?
Yeah. So sorry about that. Yes, this is. We're still kind of toying with the design a little bit, but that would be for a camera.
Okay.
And we have planned out. This would be currently planning to print this with do an SLA print for this at that same resin reason for the thin edges. And that gets I have a so this would have a kind of a hole in the body tube, kind of just basically we'd slide our avionics system up into the rocket and then just attach this on to the probe on the inside of the avionics. I just do a cut out a little bit in there.
Very nice. One of the last things, I guess, let's talk about ejection. What are you using for the ejection, and what sizes are the charges, and all of that?
So we're using, so obviously I emailed you recently, we kind of pivoted to a black powder just because we were having difficulties with our previous system. So yeah, we're using black powder. For our main, we're using 4 cc's of black powder, so it's about like 3.88 grams. And our backup, we're doing 5.3 cc's, which is about like 5.14 grams of black powder.
Okay.
That's our kind of current plan with that.
Is that for the drogue and main, or?
Yeah, so the drogue and main deployment would be the same amount of black powder because they're actually very similar volumes.
Yep.
They're like within a couple like cubic inches of each other. So yeah.
And have you had the chance to do any testing?
Yes. So I do have a video of that. Let's share my screen again. This is with those 4 cc's of black powder.
3, 2, 1.
I will point out though, in that test, we didn't quite have our main parachute packed quite right, so it kind of got stuck in the bag. We have since figured out how to fix that, and I've been, it's packed right now, so it will come out.
Okay.
I do have another video kind of just showing like it coming out, how it should, but
Good.
since we've repacked it. Yeah.
Not too bad. So one thing you can do that I'd recommend, and you can also talk with Ken about it. It looks like your recovery harness or your nylon just kind of laid in there, so it all comes out as one strand.
Mhm.
If you pack it to where they're bundled up, basically, if you make a lot of wraps with them, then put some tape around them,
Okay.
That'll shorten it up so that way it can pull that parachute bag out a lot quicker.
Okay.
So you make sure that comes out, and then when the parachute does open, that tape will just break and it will kind of be a little shock absorber. It'll absorb some of that force.
All right.
Think of that.
Oh, no, I don't know. All right. Thank you for the tip.
Yeah, you're welcome. Yeah, I usually size my ejection charges a little violent to make sure everything comes out, and I use those tape loops. A lot of times I'll have at least three different little loop bundles, and I can actually go back on the accelerometer and see during the ejection how much force kind of each loop took, and how much force was at the end of that shot cord, and kind of adjust my charges as I go forward from there.
All right.
Oh, from a safety aspect, honestly, that's all I have. You have a very well built rocket, well designed rocket so far, so definitely congratulations on that.
Thank you.
Good job with Ken of keeping y'all in line and on the right track. I guess from my side, that's about it. Do y'all have any questions for me about the rocket, the competition, what to expect, anything like that?
Um, I think so.
4 grams and 5 grams for the backup of black powder, respectively, are good amounts, right? Would you
They
recommend?
seem right in line with the volume that you're looking at.
Okay.
Of course, looking at the ejection tests uh, from that first one, usually I would like to see something separate a little bit better than that. Um, but I wouldn't say it's a safety concern. But making sure as you are doing that little pull test to make sure everything comes out, I would say is the most important part. I have had plenty of rockets separate, let's say 5 to 10 feet, and just because of how they're falling, there wasn't enough force to pull the parachute all the way out.
Okay.
Actually had that at a school competition years ago.
Um, I think we have any other questions.
Are there any frequent questions you've been getting? You've been doing a lot of these reviews. Has there been like any questions that other people have been asking that like we could maybe benefit from like, I don't know, hearing? I don't know. Does it make sense that
Um,
we just haven't considered?
my other two teams are not in the United. I started out with 6 teams, and 3 of them had to drop out for various reasons. So now I'm only down to 3 teams I'm reviewing. The other two that are still left on me are overseas, and they had more questions related to how to get the rocket here safely, what to expect in New Mexico, because they're flying in from a foreign country. Um, and one thing that I know Ken and the rest of Ezra have worked really hard on is they have covered canopies for all the student teams. That'll be permanent fixtures. All there will be tables provided, so you don't have to worry about bringing shade or tables. You just need to bring some chairs.
All right.
Uh, so that's a huge improvement that we've been making sure all the teams know about. Um, have any of your team members been to Spaceport yet?
No. So the last time Rowan was actually at an event was 2018.
Okay.
So none of us have personally been. And I actually did think of just one question. So we, for our motor, we ordered it to have it be picked up at Space for America Cup.
Mm-hmm.
Like, how does that, like, I guess, pickup like work? Like, when do we should pick it up, or like where?
Who'd you order it through?
Animal Motor Works.
Okay. So I believe that is Tim. I would say give them a call.
Okay.
Usually what they'll do is they'll get there a day or two before the competition. Sometimes they haven't gotten there until Monday or Tuesday. But kind of give them a call, see when they're planning on getting there. A lot of the times, what they'll do is they'll find a nearby parking lot that there's no buildings around or anything, he'll set up his trailer there and kind of send out on social media or contact the team saying, "Hey, I'm going to be set up here this evening. Come and get your motor." And whether you have experience kind of building level 3 motors or not, he can also help you assemble the motor there if needed.
Okay.
Do you know if your motor requires grain bonding?
I don't.
I would say definitely look up the instructions for your motor. Some motors do require the grain bonding, which sometimes the glue takes 24 hours to cure.
Okay.
So that's something to keep in mind. You don't want to wait till the morning of the competition to realize you have to wait 24 hours.
All right. Yeah, I'll definitely look. I'll find the instructions online, I think, and see what we have to do for that.
Yeah, Aerotech and CTI, they both have their instructions posted if you just go to their main website and look under resources or information. I know the little checklist I sent out for a while back for this meeting. If you kind of review that, especially the last page, there's some kind of additional hints and tips about being at Spaceport. Make sure you bring proper shade for yourself, long sleeve clothing if possible, hats, sunscreen, chapstick with SPF ratings, plenty of water. I know Ezra is also going to be sending out more detailed information about what to expect in the flow of things at the convention center, and then also at the launch field, and then also usually periodically the week before and the week of, they through Hero X they send out different little safety reminders or safety updates.
All right. Okay.
But yeah, anything else from y'all's side? Well, that's all from my side. So I'm like I said, your rocket looks great. I'm excited to see it in person and get y'all out on the field. Uh, the only recommendation I have is do some ejection charge testing to make sure that parachute comes out proper
Yeah.
to where you feel confident, and look into how to pack that shock cord to make sure everything comes out nice and even.
All right. Yeah, I did. We definitely we plan to do more. We were kind of gonna do that. We have a limited supply of black powders, so we're kind of just wait until we get the actual like system in the rocket itself and do it on the full vehicle.
That makes sense. Yeah.
Yeah, but yeah, we definitely had planned to do at least 2 more.
Okay.
One in Drogan, Maine. So.
Well, awesome. Congrats, y'all. And I know it's been hard during this final season with everything going on at school and trying to finish up the rocket. But your team's right on track with where we're hoping y'all are at, getting ready for the competition. Please, if you have any other questions or comments, contact me or reach out to Ken, and we'll be more than happy to answer any questions you have.
All right. Thank you very much. Thank you.
Thank you so much.
You're welcome. Y'all take care. Bye.
Have a good one.
Y'all too.